Okay, lesson 3, sketching parabolas for the quadratic relations unit. I'm going to show you how to draw a few parabolas based on certain characteristics. So from your lesson notes, I'm going to start with parabola number 1. Okay, so we'll call this one number 1. There we go. Okay, so parabola number 1 says draw a parabola with a vertex of 3, 4 and zeros at 1 and 5. So if we have a vertex at 3, 4, that's a good point to start on at. So if this is our x, so let's label our axes here. Always important to label the axes. So if our vertex is 3, 4, let's plot that point first. So along the x-axis, we go to 3, 1, 2, 3, and then up 4. 1, 2, 3, 4. Okay, now that is our vertex of our parabola. I don't quite know yet if it opens up or down, but from the next information where the zeros are, that will help me determine whether it opens up or down. So it says we have zeros at 1 and 5. Remember that zeros are the x-intercepts. So that means this is where they cross the x-axis. So I have two of them. I have one at number 1, or at unit 1. So there's 1, 0 at 1, and the other one is at 5. So 1, 2, 3, 4, 5. Okay, so I have my vertex is here and my x-intercepts here. From this you can see that it's going to open downwards and you can draw your curve. And remember to have your arrows to symbolize that it keeps going. Okay, let's move on to parabola number 2. So parabola number 2 says draw the parabola with a minimum value of -8 and zeros at 2 and -2. So we know it has a minimum value at -8. So 1, 2, 3, 4, 5, 6, 7, 8. So it has a minimum value at -8. The minimum value usually means that that's where the vertex is. So we know that the vertex is going to lie somewhere along this line. It also tells us that we have two zeros, or two x-intercepts, one at 2 and one at -2. Now, because we have these x-intercepts, the parabola itself has to be symmetrical. The x-intercepts will also be symmetrical, so that means that our vertex must lie directly in between the x-intercepts. In this case, it's quite easy for us to see that between -2 and 2, it will be 0. Now, the minimum value is down here at -8, so that must be where our vertex will lie. It is right in between the x-intercepts, and it is at the minimum value. So in this case, our parabola will be opening upwards. Okay, so that's number 2. Okay, on to number 3. Number 3, draw a parabola with a 0 at 1, 0. So we have one of our x-intercepts at 1, 0. And the vertex is at 3, -4. So our vertex is 1, 2, 3, 1, 2, 3, 4. So that is our vertex. Right from here, I know that this is going to be a minimum value. Our parabola is going to open upwards since one of our x-intercepts is here. And it also tells us that we have a y-intercept at 0, 5. So 1, 2, 3, 4, 5. So we know that it's going to open up this way. We can see the path. Now it's going to have to open up here too, and we want to make sure that it crosses the x-axis at the right point. Once again, because parabolas are symmetrical, the vertex will be right at the axis of symmetry. So if this is where the axis of symmetry is, so that's the axis of symmetry. If that's the axis of symmetry, then we know that the other x-intercept will lie exactly the same amount on the other side. So this has 2 units to the axis of symmetry. This one will also have 2 units outside the axis of symmetry. So from there, we can draw our curve, our parabola. There we go. Okay. Parabola number 4, last one here. So draw the parabola with axis of symmetry of x equals -2. So -2 is right along here. X equals -2 is the axis of symmetry. So we know that our parabola is going to be the same on either side of this axis of symmetry. It also has an optimal value of -3. So we know that at -3, the optimal values are going to be the y-axis, because the y is what tells us how high or how low it is. So at -3, 1, 2, 3, we have an optimal value. So we can draw a line here that demonstrates the optimal value. Optimal value. Okay, so the optimal value is there. Where the axis of symmetry and the optimal value intersect, right here will be our vertex. We know this will be our lowest point. So we have a minimum here, and we know it's going to open upwards. And then it says, oh, actually, sorry, I spoke too soon, because then it says the parabola has no zeros. If the parabola has no zeros, that means it's not going to cross the x-axis. So I spoke too soon. Sorry about that. So it's going to be pointed downwards then. If it points downwards, it will never, opens downwards, it will never cross that x-axis, and therefore it will have no zeros.